Again, it's a rich thing.
What are we going to learn in today's video?
We will learn how to program a simple voice assistant like me. By the way, subscribe to Neural 9.
What is going on, guys? Welcome back. In today's video, we're going to build a simple voice assistant in Python. So let us get right into it. Alright, so let us get started and open up a command line in order to install a couple of libraries. First of all, we're going to install speech recognition. So pip install speech recognition so that we can communicate with the voice assistant. And also the other way around, we want to know what the voice assistant is saying. So we need to install pip install pyttsx3, which is Python text-to-speech for Python 3. And then we also need the library that I have coded myself, which is neural intents. Pip install neural intents. This is a basic interface that we can use to easily build chatbots and intelligent assistants and so on. So this is what we're going to need. We're going to install them and then we're going to import them. So from neural intents, we're going to import the generic assistant. We're going to import speech recognition with an underscore. We're going to import pyttsx3stts, which is text to speech. And we're going to import sys, which is part of the core Python stack, and this is just what we're going to use to exit the program if needed. Now, what we're going to need here, as in all the other videos like chatbot and virtual assistant and so on, we're going to need an intents file because we're going to have intents, and this chatbot, this assistant, this voice assistant is going to be able to respond to us based on the intents and tags. So this intents.json file is going to look something like that. This is the one that I'm going to use for today's video. It's not complicated at all, so don't despair if you see this for the first time. It's a very simple structure. I'm going to go down here and do the same thing again. So it's basically just curly brackets. Inside of those curly brackets, then we have the first thing here, which is the intents. So intents, colon. Let me just see if I'm not blocking anything here. So let me just move this up here. There you go. So we have intents, and inside of those intents, or the intents themselves, are just a list of values. And these values are just JSON objects, which are again in curly braces. And here we have the different keys. So we have tag, we have a tag, which is something. Then we have patterns, which is something else, which is a list of something. And then we have responses, which are also a list of something. And then what's the problem here? I think this is because we already have this here. But that's the basic structure. We have intents, and inside of those intents, we have the individual intents. So this thing here is one intent. This is the intent with the tag greeting. And the greeting tag, some patterns that would fall into this category are, hey, hello, what's up, how is it going, hi, good day, and so on. Now, it's important that we provide a bunch of different samples here because this is what we use for the machine learning. The responses are going to be static. So this is what the voice assistant or the chatbot is going to give us as an answer. So hello, sir, or hello, what can I do for you? It's not just roughly what it's going to say, it's exactly what it's going to say. So this here needs to be static, and this here can be a little bit more flexible. So here we just provide a bunch of different imperfect attempts to greet the chatbot, and the chatbot is then also going to recognize similar patterns. So it doesn't have to be what's up, it can also be what is up, for example. It doesn't have to be the exact same thing. And this goes for all of those different things here. As you can see, some of them don't have any responses, and this is because as a voice assistant here, we're not interested in messages. So for example, when I say add a to-do to my list, I'm not interested in a static message like, hey, I'm going to add this to your to-do list. I'm interested in an action. And this is what we're going to do here. We're going to bind the individual tags to actions. So we're going to have a function which is going to be add to do. And this tag add to do here, if we recognize it by some of those patterns or similar patterns, we're going to trigger this function, and then it's going to do whatever we want it to do. So this is the basic structure of this project here. All right, so let's do some setup work here. We need to set up a recognizer, which is basically the speech recognition. We need to initialize a speaker, and then we need to also create the assistant. So first of all, we say recognizer is going to be speech recognition dot recognizer, and that's it actually. And then we're going to say speaker equals tts dot init, like that. And once we have that, we also say speaker dot set property, and here you can also set the rate, so depending on how fast you want your assistant to talk. So for example, if we do something like 300, it's going to be quite fast. If we do something like 20, it's going to talk in slow motion. I use something like 150, and that's a good speed for me. So what we're also going to have here, as you saw in the JSON file, we're going to have a to-do list. Oh, by the way, let me just remove that here. We're going to have a to-do list, so we're going to add to the to-do list, we're going to show the to-do list, and because of that, we should have an object, which is the actual to-do list. And for this, we're going to say just to-do list. It's going to be an empty list, or actually it's not going to be empty. We're going to start with some values, go shopping, clean room, and I don't know, record video, like that. So this is the to-do list. Now, what we need to have here is we want to train a model that is going to recognize the intents and is then going to map them to a function. And for this, we're going to use the library neural intents that I've written, and we're going to say assistant is going to be generic assistant, and here we need to specify the path to the intent file. So intents.json is going to be the file. And what we can also provide is some mappings, but we're not going to do that yet because we don't have functions, but I'm going to talk about the basic functionality of this in a second here. Once we have that, we're going to say assistant.trainModel, and actually that's all we need to do. So what we're doing here is we're just specifying the intents JSON file, we're training the model, and then the model is already trained, and once it's trained, we can just call assistant.request. And if we request something, we pass a message here. So for example, how are you? And if it's recognizing that as an attempt, it's going to give us the right response. So it's going to look, okay, how are you? Can I fit this somewhere in here? So for example, this could be greeting. So I'm going to respond with hello, sir. Or if I have a function mapped to it, so if we don't have a response, but we have a function mapped to this specific tag, it's going to execute that function. So, but this is what we're going to do later on. The basic idea here is that we have some function. Let's say we have some function here. And this function does print hello world, for example. And if we want that function to be called when a certain intent is recognized, then we just have to specify a mapping. So we can say mappings, and the mappings are going to say, for example, let's say for greeting, we want to execute that function. If we recognize the tag greeting, so if the assistant recognizes that my message, my input was of the intent greeting, then it's going to be executing the function SomeFunction. Now it's important that we don't call the function, we pass the function. So once we have that, we can then go ahead and say intent methods is going to be mappings. And this is all we need to do. By doing that, we provide a dictionary that says, okay, this tag means calling that function. And those are the intents. And then we just have to request, and depending on if there is a function in the mappings here, we're just going to execute that function. And if there's no function, we're just going to return the responses that we have statically typed here. So this is the basic structure. Now we have talked about all of this in previous videos already. So what is the new part here? The new part is that we're going to use voice. We're not going to just chat with the bot. We're going to actually talk to it and get voice output as well. So let's implement the first function, which is create a node. So we're going to have this tag create node here. It's going to be triggered by something like, please create a new node. I want to create a new node, create a node, new node, and so on. So anything that has the phrase new node in it will probably be recognized. So here we're going to say create node. This is going to be the function, and it's not going to be a small function actually. So let's just get rid of this here and of this here. There you go. So this is going to be a very basic function, even though it's not going to be small. And we're going to say global recognizer so that we can work with it. And then we're going to say something. So we're going to say, what do you actually want to add to your node? And for this, we need to say speaker.say, what do you want to write onto your note, question mark. And in order to actually say this, we need to say speaker run and wait, like that. And once we have that, we're going to just wait for the user input. And this has to be done a little bit more complicated. We cannot just say input, but we need to actually go in a loop, because sometimes this loop is going to fail and then we don't want the program to end, but we want to try again and so on. So what we're going to do is we're going to say done equals false. And then we're going to say while not done. While we're not done, we're going to try to process the input of the user. So we're going to say with speech recognition dot microphone as mic, we're going to say recognizer dot adjust for ambient noise mic duration equals 0.2, and you can tweak that value if you want. But what do we have here? Actually, why is it? Oh yeah, because we need an accept. So we do recognizer just for ambient noise, microphone duration 0.2, and then we say audio is what we get there. So recognizer.listen mic. So this is the audio part. It's going to have this threshold here, or it's going to recognize when we're talking based on this value here. And once we're talking, once it's recognizing us, we're going to save what we say into the audio variable here. And then, of course, we don't want to just, come on, what do we have here? Yeah. Then what we want to do is we want to extract the text from that audio. So what we want to do is we want to say note equals recognizer dot recognize Google. Of course, you can also use IBM, Bing, and other companies, but we're going to just use Google here. And we're going to recognize what's being said in that audio. And then note equals note.lower, so that we don't have any confusion with the case. This is going to be the note that we just put in via the microphone. However, then we're still not done, because then what we want to do is we want to actually also choose a file name. So what we're going to do then is we're going to say speaker.say choose a file name. And of course, speaker.run and wait. And then recognizer just dot adjust for ambient noise. Microphone duration 0.2. And then again, audio equals recognizer dot listen. And we're going to listen to the microphone. So let's recenter this again. Now, once we have that, we're going to do the same thing. File name equals recognizer dot recognize Google audio, and file name equals file name dot lower. Now, of course, this with the file name is going to be a little bit tricky, because it's always going to have some spaces if you use more than one word, but that's an optional thing that you can do here. Now, what's important then is if this worked, we're going to say with open file name. So we're going to use the file name to open a file, to write into it SF, and what we're going to write into it is going to be the note. So f write note. And if that is done, we're going to set done to true, because then we're done with the process. And we're going to also say speaker, say I successfully created the note, and then we're going to add file name to it, which makes it an F string. And then, of course, we're going to say again speaker dot run and wait. Now, what happens if all of this goes wrong? If sometimes it doesn't recognize what we're saying, in this case, we're going to get an exception. So we're going to say except, and the exception that we're waiting for is going to be the speech recognition dot unknown value error. So if that exception occurs, what we're going to do is we're just going to reinitialize the recognizer. We're going to say recognizer equals speech recognition dot recognizer. So we make a new instance, and then we say speaker dot say I did not understand you. Please try again, like that. Speaker dot run and wait. And since we are in a while loop, we're not going to break out of it. We're just going to get the exception, and then it's going to start all over again. So this is the basic create node function. So next, let us also implement a simple add to-do function just for adding some to-do list, something to the to-do list. We're going to say def add to-do. And here we're also going to say global recognizer. I'm going to speed this up a little bit because it's actually the same. So global recognizer, then speaker.say what to-do do you want to add, like that. Speaker.run and wait. And then again, done equals false, because we can always make mistakes. While not done, try with speech recognition microphone as mic. We're going to say recognizer dot adjust for ambient noise, mic duration 0.2, audio recognizer listen mic. And the item that we want to add to the to-do list is going to be recognizer dot recognize Google, the audio item equals item dot lower, and then if that is done, to-do list dot append the item, and once that is done, we're going to say, okay, mission complete, done equals true, and the speaker is going to say I added item to the to-do list. Actually, most of the time it's pronouncing it to-do list. So maybe if we do to-do list, it's going to say to-do list. Let's see. And of course we need to say speaker dot run and wait. And again, except if we get this unknown value error, so speech recognition unknown value error. If that is the case, we're just going to again reinstantiate the recognizer by saying speech recognition dot recognizer, and we're going to say speaker dot say I did not understand, please try again. Speaker dot run and wait, like that. So this is the basic add to do function, and then we can also make this simple show to do function, which is just def show to dos, like that. And this is just going to iterate over the to-do list. So we're going to say, we don't need any interaction here. We don't need to listen to the user. So we need to say speaker, say the items on your to-do list are the following. And then for item in to-do list, we're going to have speaker say this particular item. Actually, we don't need an F string here. We can just say item. And of course, in the end, speaker dot run and wait. There you go. And last but not least, the only thing that I want to add here is the exit. Or actually, we can also add the greetings, because the problem as of right now with this module is that I don't have implemented that the responses can be put out via voice. Now, it's not a hard thing to do, but I haven't done it. So what we can do is we can also implement a function for greetings. So def, well, let's just call it hello. Def hello is going to be speaker.say hello, what can I do for you? Question mark. Speaker.run and wait, nothing too complicated. And then def quit, or whatever we want to call it, exit or buy or quit or whatever. We're going to, or what is it called actually? Exit. But I think exit is already a term in Python, so I'm going to use quit. And here we're just going to say speaker.say by speaker.run and wait, and then sys.exit 0, like that. So those are all the functions. What we now need to do, again, is we need to create a mapping dictionary. So we're going to say mappings is going to be this dictionary here. And we're going to map greetings, or was it greeting or greetings? Greeting. We're going to map greeting to hello. So whenever it recognizes that the tag is greeting, it's going to call the function hello. Whenever it recognizes that it's create node, it's going to call the create node function. Whenever it recognizes that it's trying to add a to-do, it's going to add a to-do. Whenever it's trying to show to-dos, it's going to show to-dos. And whenever it is trying to exit, we're going to call quit. There you go. So those are the mappings. Here we now need to say intent methods equals mappings. And then what we're going to do down here is we're going to say assistant, or actually we already have the training. So now we need to go into the endless loop of interacting with the assistant. So we're going to say while true, we're going to try with speech recognition dot microphone as mic. We're going to say recognizer dot adjust for ambient noise, mic duration equals 0.2. Let me just center this. And then we're going to say audio equals recognizer dot listen to the microphone. And then the message that we're saying to the voice assistant is going to be recognizer dot recognize Google audio, and then message is going to be message dot lower. And we're going to say assistant dot request, and we're going to request the message because this is the basic function. This function is either going to give us a response or it's going to trigger those functions here. It's going to call them. So this is the basic request. And in the case that we get the basic unknown value error, we're going to just do nothing. We're going to reinstantiate this. We're not going to even say something. We're just going to wait for another input, because if you're interacting with a voice assistant, you say something and it ignores you, you're just going to try again. So this is kind of intuitive. All right, so let's give it a try. We're just going to run it and see if it works. By the way, one thing that I want to mention in between here is that when we train the model, we can save it and load it by just saying assistant.save model and .load model. So we don't need to train it every time we run this assistant. So I can show you that in a second. Hello.
Hello. What can I do for you?
Add an item to my to-do list.
What to-do do you want to add?
Test task.
I added test task to the to-do list.
Show my to-do list.
The items on your to-do list are the following: go shopping, clean room, record video, test task.
Create a new note.
What do you want to write onto your note?
This is just a basic test note.
Choose a file name.
My note.
I successfully created the note my note.
I want to exit.
Bye.
There you go. Works perfectly fine. We can now go to my note. You can see this is just a basic test note. Now, of course, we can also, instead of just opening the file name, we can say, when we name the note, we can just append a txt. Where was it? Open file name. We can also add f string here, file name, and .txt, like that, if you want to. So other than that, it worked perfectly fine as you saw. Now, again, what you can do is you can go ahead and say assistant.save model if you want to. And then next time assistant.load model. You don't even need to specify any parameters. If you want to use the default name, it's going to be done automatically for you. But that is how you build a simple voice assistant in Python. Alright, so that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video, and bye.